Hi and welcome, it's Gene from Maverickstar Observatory. First of all, apologies for the noise in the background. That's the 3D printer running off the first model of what we're looking at here. What we're looking at is the 2 prime gears that we're going to be using in the motor that we've proposed to build over the next week or so. The reason for this is because we know we've got probably around about 2.7 years before the geomagnetic reversal possibly goes into full swing, and I believe at that point we could benefit from anything we can learn with regards to powering our homes, albeit by ourselves if need be. It's experimental stages, and theoretically what I'm proposing should work. I'll get into a little bit more detail and show you what we're printing off at the moment. We've got some of the smaller spurred gears manufactured, and we're just printing at the moment. In the background you can hear the printer going. One of the larger spur gears that fits on the motor that drives the gearbox, which should give us more torque in order for us to run at least several, hopefully 12 motors, as well as some coils, which I'll explain a bit later. But before we get into it a little bit more, big thanks to you few guys that are supporting what we do. I'm probably going to go over the same thing a couple of times there, but really the main thing is supporting each other in order to try and achieve the goals that we want to set out. I think everyone would like at some point in the near future to be able to have a module, if we can succeed in that, that can run a proportion of the household utilities, and if not all of them. It just depends on how successful this project is, and the prototype, how well it runs, as to just a case of scaling it up and using bigger motors, bigger generators, etc. So what we're trying to do here at the observatory is not just focus on like we have done for the last 10 years, the geomagnetic reversal, but also focus on another prime concern of all ours, which is the ever increasing costs of energy. And if we can bring those down using technology, then why shouldn't we have at least a go at that? That's what I'm saying. And there is no guarantees that we can achieve it, but I'm not one of these people that look pessimistically at things. I think if you're going to have a go at anything, you've got to start off with the attitude that there's a possibility. And I'm very optimistic, and so I've got the time and effort to put into this. What I don't have, as you guys know, is pockets full of money, and I'm just hoping that a few more of us chip into this. And I said at the beginning of this project, I'll put it out there, free source, and if most of this can be built with 3D printers, then it drops the costs down for the actual person that wants to build it themselves, as opposed to the person that wants to buy it. I'm not going to patent any of this. I'm not interested. I always believe that the patent office is just an ideas box that can be stolen by anyone that wants to backdate your original idea. So you do it like I have done in the past, done a search, and it's come back no ideas remotely close to what I've designed before and built. And then later on, when the patent's expired, lo and behold, someone had put a patent in before I'd done the search, and they'd made a claim on it. So what I'm saying here, guys, is I don't mind if at the end of this we do get a successful motor. I'll put it out there as free source, and everyone can have the benefits of it. What I'm looking for is more people like-minded that want to support such a task. And I know it doesn't seem a lot, but the costs can easily escalate. I mean, we're not just talking about the electric that's running the 3D printer to start with. We're not just talking about the filament that runs the printhead. It's the time, it's all the other things that are in the background, like these 3D CAD programs, And then you've got your slicers on top of that, which you need to put into machine code so that the 3D printer can understand what it is that you're actually asking it to build, you know. And then there's the skill set, and we've got multiple skill sets here. You know, I'm lucky that I can get my head around computer-aided design programs, use 3D printers, because they're art in their own selves. You know, you have to set just in the 3D printer, you have to set the bed temperature, the print head temperature, you have to set the print head fan speeds, you know, the actual printing speed has to be set, and there's a lot of learning curves just in 3D printing components. So, you know, when you put all these skills together, you know, you could easily be talking 6 or 7 people with, you know, the major single skill set that we don't have to pay to do the work for us. And that's, you know, if this requires electronics, programming and all the other things that could be involved in this, then, you know, we've got the skill set again to do that. So we're very lucky, you know, that I'm not being big-headed or anything like that, you know that, guys, but what I'm saying is we're very lucky that I've got a wide range of skills that I can apply to this, as well as a lot of knowledge in you know, failed attempts and recreating other people's claims that claim to have, you know, have built objects like this that actually work. So this is my own idea, and like I say, I believe it can work if we use a multitude, instead of just using like the majority of people do on YouTube that, you know, claim to have 0 point energy producing motors. You know, what I'm saying here is if we take another approach and we add or incorporate lots of other technologies into this, I believe we can get a winning formula back out of it. And I'm prepared to give it a shot, especially, you know, when we are faced with a time approaching where we could do this 5 years ago already. You know, I think you'll agree with me, electricity or energy in general is getting more and more expensive, and it's probably one of the household costs which, you know, requires you to go to work in order for you to obtain that. If we can eliminate things like this, if we can grow a certain amount of food ourselves, and I want to look into projects, you know, perhaps next year, growing, you know, particular types of food that grow fast, that regenerate very quickly, and, you know, can feed a few people in a family, if not sustain a small family from a small growing area. But that's going to require, again, you know, technology. You know, people have had goes at these things many times and failed, and I know people have invested tens of thousands of pounds into these things and failed. So, you know, it's not easy. These tasks that we're setting ourselves out now are not the easiest of things to do, but, you know, it shouldn't put us off, you know, trying to achieve them. You know, if we was going to think like this, we never probably would have had a rocket to start with to get us out of the atmosphere into space. So it's sad that, you know, we're faced with times where, you know, people don't want to work together. People don't see the value in good ideas like these, and, you know, they're not prepared to take any chances or risks. And, you know, for them, they're happy to pay the bills. You know, we're not all in that same boat where, you know, we can all afford to just keep throwing money away on these things. So I think there is a problem there that we should try and address, and that's what we're doing here with this. I'll just show you the video of the 3D printer printing the main spur gear, which is going to be driven by our high torque motor at the centre, and I'll be running some tests over the next couple of days to see how we get on. But tomorrow is Wednesday, and if you know what happens on a Wednesday, it's the Earth Health at a glance, and because it's the 16th tomorrow of December, I'm also going to take the data out the SD card and process that data as well. So we're going to have an Earth Alpha at a glance and a latest magnetic pole position all in one video tomorrow for us. And I suppose days after that we can just carry on with the progress of what we're doing here, and if we get any data from any of the other stations that we've got around the world, then we'll bring that in as well. Guys, what this is all about is just trying to do as much as I can. Simple as that. And in no short of anything else, it'd just be great if we can get some support financially to continue doing this. And it doesn't require people putting in hundreds of pounds if they can't afford it. If everyone chips in, then we don't have to all put so much. But it don't work like that. This isn't an ideal world, is it, that we live in? And even though we've got supporters and subscribers that have been with us for a long time on YouTube, they still today haven't felt that at this point that they should be investing in it. But at what point are they ever gonna? That's the question. So let's run the video. I'm gonna say what I usually do, bye for now, but I'll run the video, the last part of the video, where I'll show you the 3D printing, and I'll just mention there's a link down there if you want to help support any of this that we do at the observatory. It's not just building this motor, it's all the other things, and I'm sure if you follow me you're aware of that. And the only other thing to say is thanks guys for those that do support it. But we're at one of the worst points in the year, and we're trying our hardest. It would just great if a few more people would jump up and give a little bit of help. But there you go. I'll say what I usually do. I'll say bye for now, and just enjoy the rest of the video as always. Bye for now. Report on how we're getting on with building the motor. If you've never seen the last couple of series, we've decided to have a go at just creating a small generator that can run highly efficiently, perhaps incorporating more than one technology. What we're printing off here is the first of the two gears. You can see these smaller ones here. They've got a ratio, or a gear ratio, of 6. The larger one that we're printing off, as you can see, has got a lot more teeth. It's actually 100 teeth, so it's 106 to sorry, it's 100 to 6 ratio on that. And this big wheel will turn at 1 revolution every 2 seconds, so it gives you an idea how fast these little ones should spin. There's a lot of work that goes into this, and this is what I was saying, and trying to explain to people. One of us can, put the time and the effort and the money in. Obviously, we're using materials, electricity, wear and tear on the machines. When you add, the time that you've got to invest to be able to use the CAD, computer-aided design programs, then just buying a 3D printer isn't the end of it. You have to buy a slicer, which is another 120 quid. The costs start to mount up, and that's before you've even included your own time. But the point is that one of us invests the time, we share the cost, and we all share the outcome of the results. And like I say, I'm pretty confident that we can create a generator that can run a home using multiple methods. We're going to see how we get on first of all with the DC motors that are going to act as little generators. There's going to be 12 running around the outer ring, being driven by a high torque motor in the centre, and we're also going to have another ring on the top of this one mounted with neodymium magnets, these going all the way around the outside, which are going to energise a coil like that. 12 of those coils all around the outside. So not only have we got 12 DC motors generating electricity, we've also got 12 of these coils generating electric. And if the system falls short of being able to maintain its own momentum, we can add in a little bit of solar power and also wind generator. We can actually turn this into a wind generator as well, to alleviate some of the you know, the what's the word I'm looking for? Oh dearie me. Some of the torque that would be put on there, which would slow it down. If we can remove some of that and make it more efficient every time we give it a little bit extra help to go around, you know, that's saving energy, and we should get that back at some point. I mean, obviously, some people are thinking, well, why don't you just use solar power? You get instant power and you can bank that in a battery. The idea is something else, guys. You know, I'm not trying to create perpetual motion, but let's see how far we can get to over Unity. Let's see if we can get it to run itself using its own power. And if not, let's see if we can incorporate another technology which we can obtain through, like either harnessing the sun's radiation through photovoltaic cells, solar panels, or wind. And let's see how far we can go with this. You know, let's have a real good shot at it. That's what I'm trying to do. But you know, it's going to need a little bit of support from you guys as well. You know, I can invest the time, the knowledge that I've got in computer-aided design, using 3D printers and electronics, and obviously, you know, my knowledge in magnetics is quite extensive. You know, let's see what we can get out of it as a result. That's the main thing.